Hello, welcome to today's presentation. My name is Ted Blowe. I'm the Director of Engineering at SDA Software, and today's topic is Introduction to Simcenter STAR-CCM+. Brief agenda of what I'm going to be talking about today. First, I'm going to give a background behind SDA and SDA Software. Then I'll talk about some industry-wide challenges and the associated business impact. I'll discuss a new way forward with Simcenter, and then give a brief overview of the Siemens provided CFD solutions. And then I'll jump into today's demonstration of a ball valve using Simcenter STAR-CCM+. And then I'll end with a success story and field any questions. So who is SDA and SDA Software? SDA is a engineering consulting company that provides simulation and design services primarily to the aerospace industry. And SDA Software is a Siemens National Platinum reseller, and our specialty is the Simcenter portfolio, which I'll be highlighting later. And our headquarters is in Sterling, Virginia, and we have sales and technical coverage across the US. Here are some projects that SDA has completed, and you can see that it's both space and air with also UAV and then some other projects. So if you have any questions about this, please feel to reach out. Like I said, SDA Software, our specialty is the Simcenter portfolio, including FEMAP, STAR-CCM+, and others. We offer training, support, services, and that's background about the company. So moving forward, business is changing and we need to change with it. Here, I just want to highlight a couple things that executives are saying. First, executives agree that innovation is critical for their business to grow. And they're also saying that customization of their products is a major competitive differentiator. And in the demonstration, I'm going to show you how you can innovate and customize with Simcenter STAR-CCM+. But first, let's talk about Simcenter. What is Simcenter? What is included and how does it interact? Simcenter is the simulation portfolio from system simulation like Simcenter AIM-Sim to component simulation or vehicle simulation for CFD, FEA, or other multiphysics offerings. And there's also the testing hardware and software. And one thing that I'm going to cover later is how Simcenter STAR-CCM+ can integrate with HEADS, which is a design exploration algorithm, and Teamcenter, which is a PLM data management solution. What are the different CFD options? Who are they for? And what are the pros and cons? For a lightweight CFD solution, there's Simcenter Flow EFD, and this is primarily targeted for design engineers, mechanical engineers. And then we have Simcenter FlowTherm, which is a specific electronics cooling solution for thermal engineers. And it's targeted because of the libraries with built-in components that come with the solution. So you're able to get the software and plug your components in so that you can very quickly and accurately recreate your configuration. Then there's Simcenter 3D, which is a solution for FEA engineers. And one of the key offerings is the TMG solver, which is an advanced space systems thermal radiation solver. And then finally, there is the flagship CFD solution, Simcenter STAR-CCM Plus, that is both integrated and has advanced multiphysics, and we're going to dive into this later. But at this point, I just want to emphasize there is a solution for everyone. If you're a designer, analyst, or researcher, there's a solution for you. Like I said before, Flow EFD is made for designers. It's CAD embedded. And for general multi-purpose problem, there's Simcenter STAR-CCM Plus. What is the difference between CAD embedded and traditional CFD? In this case, we can think of Flow EFD as a CAD embedded, and Simcenter STAR-CCM Plus is a traditional CFD. And the key takeaways from this table is that CAD embedded is lightweight. You can run it on a laptop. You don't need additional HPC resources. You don't need to be a CFD expert, and you can solve basic CFD problems. The limitation is that it doesn't have the advanced multiphysics capability, which is where Simcenter STAR-CCM Plus enters the picture. It does have a very high capability. It can solve a wide range of multiphysics problems. But with that comes the requirement for HPC resources. It comes the requirement for a CFD expert. So different solutions for different projects and organizations, and it just depends on what your needs are. I saw this LinkedIn poll by Holger Marshall, and he asked, what are the biggest challenges for you to adopt CFD for an industrial application? I kind of see this as a general CFD adoption question. And you can see there's 500 votes, and the number one by far is the cost of licensing, followed by model preparation and simulation speed. And I just want to emphasize, whenever we're approaching the question of should this project or should our organization be adopting CFD, the very first question we need to ask ourselves is, what is the return on investment? In some cases, there's a hard, a 1% improvement is going to be, like, for example, I had a customer who said a 1% improvement is going to be a $2 million return on investment. Okay, that's pretty clear direction. I've had other customers say, well, it's hard to quantify, but it's really important for emphasizing our offering as a technical differentiator. So in some cases, you can quantify it. In other cases, it's more subjective. But before we get into the details, that's the question we need to ask and internalize before approaching these other options. Second, in terms of the cost of licensing, there are many options. This is why I highlighted the CAD embedded solution, because the cost of the license, everything is affected. The cost is significantly reduced across the board at the compromise of the advanced multiphysics offering, which wouldn't be available. So what I want to communicate in this slide is that we are committed to your project success, whether that's as services or software, and there's not one size fits all, and we can do a lot of things to reduce the cost or be efficient. So I just wanted to highlight this because I thought it was a really interesting question. Okay, now it's time to dive into Simcenter STAR-CCM Plus, a brief overview of this tool. What I'm going to be emphasizing in this presentation a lot is integrated workflows and advanced multiphysics. In the pictures you see here, we see some of the advanced multiphysics offerings, from marine application to turbine, multi-phase, Eulerian, Lagrangian, VOF. We have species interactions with the combustion, mixing, and the external aerodynamic analysis. Here are a couple more examples. On the top left, we see motion combined with the electromagnetism. On the top right is a special add-on module, which is the in-cylinder simulation, and that allows you to model the atomization and combustion characteristics inside of a cylinder. And the bottom left is a marine example of a vessel going through waves, and on the bottom right is external aerodynamics. Workflow automation. What does it mean to be integrated? STAR-CCM Plus, you have the ability, let me just highlight these. A key value add is that you can import your CAD, create the volume mesh, set up the physics and solve your solution, and post-process the results in one integrated user interface. And in addition to that, you're able to make a change, say in the CAD, which I'm going to show later, and propagate it through the workflow with minimal interaction. So it's integrated and it's self-contained. Here's the design exploration. This is built in to the tool. This is showing an intelligent design exploration of a mixing tank where we changed the, it looks like the angle of attack. We changed the number of mixtures, the chord length, the baffle configuration. And with these inputs, the intelligent optimization design manager is able to examine and output an optimized design. Another thing I want to emphasize is that STAR-CCM Plus is scalable. If you have a large production problem that requires tens of thousands of cores, this is a good solution. Not only that, the main default license has unlimited cores. So you don't have to buy individual core packs to get more availability to adopt more cores. It comes with the default license. Like I said before, in addition to the default license, there's power on demand, which is a pay as you go to rent a production license. And there's also tokens as well as cloud enabled credits. So you can use the interface directly to access the license and solve. Okay, now we're ready to jump into the demonstration. And the demo today is going to focus on the workflow that I previously described and the design exploration capability of a simple ball valve problem. And so first I'm going to show how we can use Simcenter STAR-CCM Plus to obtain detailed engineering insights into the valve performance. Then I'm going to quickly and simply generate and test design variants within the tool. And finally, I'm going to look at different ways we can automate a design change for exploration purposes. Again, the focus of the demonstration is on the workflow, and this happens in three main phases: the build, test, and assess. In the build phase, this begins with the CAD, where we manipulate and prepare the domain for computational discretization or meshing. In many cases, a significant amount of time can be spent on developing the first volume mesh, and Siemens has invested much development effort into reducing the time it takes to create that volume mesh. Then we have the test phase, and this represents the validated physics models available in the software. And all of I would say, except for a couple of special examples, like I showed before, the in-cylinder, there's also a battery design module. But besides those, all of the multi-physics capabilities are available with the default licensing. And then finally, we have the assess phase, and this is where we evaluate the results of the simulation, where we can extract some detailed engineering insights. And finally, I just want to highlight one of the key differentiators and value adds of STAR-CCM Plus is that all of these phases are incorporated in the same user interface using the default license. You don't have to have special licenses for different phases, even though there are add-ons that you can get. And we're not going back and forth between different meshers, solvers, and post-processors. This enables us to revisit the build phase and quickly transition to the assess phase with minimal interaction. So we begin with the build phase, and what I'm going to show you first is a tour of the intuitive graphical user interface. Then I'm going to prepare the CAD for volume meshing by creating end caps on the inlet and two outlet surfaces. With these end caps, I'll be able to extract the fluid volume and then assign this domain part to a region so I can set the boundary condition types. And then finally, I will create the automated volume mesh. Okay, so let's dive into the demo. Okay, so here is the user interface. On the top left, we have the simulation tree, and this represents the different phases of the workflow. Below, we have the property window, which is where we enter the specific information for the associated selection in the simulation tree. Below, we have the output window, which gives us the output of the current operation. And in the main viewing window, we have the model where we interact. Okay, so while I create these end caps and prepare the CAD for meshing and mesh, I just want to highlight some of the CAD related value adds that are available with STAR-CCM Plus. And the first is the NX to STAR-CCM Plus. And what that means is if you're an NX user, you have the ability to get this add-on where you have CAD client bidirectional transfer of parametric data. And what this means is that in NX, you're able to define your CAD parametrically or define, different characteristics parametrically that you want to change or explore. And you're able to connect directly to STAR-CCM Plus and have the CFD analyst access those parameters, modify those parameters, and then have it send back to the NX designer. And that's very powerful, especially if you're in a PLM configuration. And then the other CAD add-ons is the CAD Exchange, which gives you the ability to interact with CAD native file types. So for example, I'm working with a customer who uses SolidWorks, and I'm able to directly interact with those part files, which is beneficial because I'm able to see the exact same surfaces that the designer is able to see, which is very helpful. And then finally, STAR-CCM Plus without any add-ons has the ability to interact with the CAD neutral file types, and it's best to use parasolid file type, and that's the period x_teeth. And that's important because that's the Siemens kernel, and that's what's recommended. Okay, so Now ready to volume mesh. Okay. Okay, so I just ran through all of the uh, the the build actions, and you can see while I was talking, I was able to significantly reduce the pre-processing time by quickly interacting with the CAD model itself using the CAD preparations, the fill holes and extract fluid volume. And this improves our accuracy to maintain associativity to the design data, which enables us to have quick and accurate investigation of our early design concepts. Okay, now we're ready to move on to the test phase. And in this section, I'm going to create the physics continua and select the physics models through an interactive wizard for our problem today. And it's going to be steady state water flowing through our valve assembly. I'm then going to change the inlet mass flow rate and then adjust the stopping criteria. Okay, let's jump into the demo again. So while I'm selecting the models, I just want to emphasize the design paradigm behind STAR-CCM Plus. And Siemens and previously CD APCO has taken the design approach of developing the code so that the different physics models are able to interact with each other. And this is obviously not true for every case, but that is the design approach and intent that they've taken. And so what this means is that you are able to model different multiphysics in the same simulation. And furthermore, what it means is that models are not siloed so that you can only use them one at a time. Okay, I'm just going to adjust the stopping criteria because I know it converges pretty fast. And that concludes the test phase. So I was, in the matter of seconds, able to quickly and easily select our models for today's simulation. And this is going to allow us to investigate a variety of different scenarios and increase our accuracy and throughout the design cycle. Okay, now we're ready to move to the assess phase. And in this phase, I'm going to create mass flow rate reports on the outlet surfaces and pressure drop reports between the inlet and the two outlet surfaces. Then I'm going to create a scalar and vector scenes of the pressure and velocity fields so that we can visualize the results. And then finally, I'm going to run the simulation. Okay, one thing to note about Simcenter STAR-CCM Plus is that there's no hidden residuals. All of the residuals are shown when you run the simulation, and that's so that you can understand how your simulation performs without anything going on in the background. Nope. Okay. And then another thing I want to emphasize is that the reports that I'm using today are built in, and that's really helpful because I don't have to create any custom script. If I want to know the flow rate on these surfaces, there's a report for this report. There's a report for this function. Okay. And the reason why I'm creating these reports is so that these are engineering quantities of interest that we want to view as the simulation progresses. And this is another important way of tracking conversions. Okay, so from these reports, I can create monitors and plots. And this is one of the tools we're going to use to understand conversions. Okay. Now I'm ready to create our scenes. Okay. So one of the attributes that I really like about the post-processing is that I'm able to include multiple scenes in the same view. So in this example, I'm showing that we can view pressure on a cut plane through our geometry. And in the same scene, I can add the velocity vector field on the same surface so that we can see the pressure and velocity on the same view. And we can highlight that by changing the color bar. Okay, so now we have set up our reports and plots and scalar scenes before we run so that we can understand and visualize our results. Okay, we can see that the residuals automatically pop up. And we see that both the pressure drop and mass flow converge very quickly. In the inlet region, we see a high pressure field as well as a high pressure field in the back of our assembly, which indicates the stagnation point. And this is where we see the flow redirect to the 2 outlet. Okay. So the value here that I just showed, I just created what we can think of as a baseline CFD simulation. And I was able to do that very quickly to create a concept design of our fluid component and analyze its behavior. Now that we've completed the 3 basic phases, we are now going into the exploration, the design exploration phase. And in this simulation, we defined a parametric value that's associated with the valve position called rotate angle. And so I'm going to revisit the build work phase, the phase, and change this parameter, which is going to modify the geometry. And then I'm going to propagate that through the entire workflow. And then I'm going to increase our stopping criteria, rerun the simulation, and then at the end, I'm going to show you how we can automate this change. Okay, so let's jump back in. Okay, so here's our previous run. I'm going to revisit the geometry phase, and we can see that rotate angle is a parameter that's defined. And I'm just going to show the geometry scene so that we can see how this change is going to impact our model. And I'm just going to change the opacity so that we can understand the ball valve configuration. So here you can see it's at 0 degrees, totally open. Okay, so now I'm going to change this parameter to 60 degrees. And when I did that, you see that there are warning indications next to the CAD and mesh. And what this means is that a change has been made and the current configuration, is not as it was before. And what I like to do as a debugging tool is to execute the CAD operations first, because often in a production simulation, You may have millions or tens of millions of cells, and it may take some time to mesh. So I like to check the CAD operations first before meshing to confirm this is actually the behavior I want to see. And as you can see, the valve position has rotated in the counterclockwise direction 60 degrees. This is the behavior we want to see, and that gives us the confidence to remesh. You can see here in the properties called mesher execution mode, I have it set to serial, but you are able to get a couple of multiplication factors by changing it to parallel, which is one of the ways Siemens has enabled you to speed up your volume meshing. Okay, let's view the volume mesh. So by changing that parameter and propagating it through our build workflow, we're able to see that the mesh updated automatically. I didn't have to go visit anything else. I just made the change and executed it. And now I'm going to increase the stopping criteria so that we can run on top of the previous simulation. Okay. So while it's running, we can see that the mass flow to this first outlet, which is this outlet, has been totally cut off. The value is 0. So all of the flow is being redirected to the second outlet. And we can see that the values converge pretty quickly. And the pressure and velocity fields, we can just double check the residuals also converge. And we can see how the flow is redirected. So what I just showed you is a manual way of making a design change. So we had a parameter, I adjusted the parameter, and then propagated that through the workflows. Now, there's a couple different ways you can automate this. One thing to note is that the API comes with the software. You don't have to pay any extra. It comes with the software. You're able to download it, access it, and the API is written in Java, which they recommend use NetBeans. And I have customers who they use Python and they want to do their automation using Python. And so we have to first create the Java code and then take the Python to manipulate that Java code and execute it through their workflows. And that's one way. Another way is using the simulation operations. So here's a design parameter. Let me change this to a general parameter. And in the automation folder, we can see that our parameter has been set. We could probably change this to a vector type and have several different positions defined. And then in simulation operations, we create a new operation. And in this case, we can set our parameter. In this case, it's rotate angle. We can set this to a different value. We can also set an index and then iterate it through. We can loop it through our rotate angle if we define it as a vector. But this is just for demonstration. So set a parameter. And then next, I want to execute the volume mesh. And what this means is it's going to execute through all of the operations to volume meshing. So we set our parameter to a new value, we have the mesh, and then we're able to solve the physics and then maybe save the simulation. So if we put this in a loop, and then we can put this in a loop. So this is a lightweight way of automating a design change. And then finally, you can create a design manager project, which also comes with the software. And in this project, I defined a manual sweep of our rotate angle from 0 to 90 degrees at 10-degree increments. And so the rotate angle is like a design input. And our outputs that we're interested in are the mass flow rate and the pressure drop reports that I previously created. And by running the simulation, after creating the design manager project, we can see through this project interface that the selection is highlighted in all of the scenes. So we can see that this is design 3 at 20 degrees, and we can see the velocity, pressure, and mesh at that configuration. And what this allows us to do is conveniently understand interactively how different design configurations impact the performance, making it easier, reducing the barriers for us to make informed design decisions. And the value here is that STAR-CCM Plus makes it easy for you to not only create, but to change the design of your system and making it a lot quicker and easier to make decisions so that you can innovate faster and have a more customized solution. So in summary, what I showed you today is first I created a baseline valve simulation. Then I manually changed a design parameter. And then I showed you a couple different ways how we can automate a design change. So I just want to highlight a customer success. Kawasaki Heavy Industries, and specifically their motorcycle division, is responsible for the development of the Ninja H2R, which is a high performance motorcycle. This is very challenging because they need to manage the heat generated by the engine and also provide aerodynamic devices so that the motorcycle is stable at high speeds. And their development team adopted Simcenter STAR-CCM Plus and the automation capabilities that I showed you today. And by doing this, they were able to cut down the development time by 75% over their previous process, which basically means they get a better design and a lot less time. Okay, so that completes today's presentation, and I can now take questions. Does anyone have any questions? Okay, so here's a question that just came in. We usually outsource our CFD work. Is there a path forward for using the software ourselves and mentoring? Yeah, I mean, this is one of our strategic goals, is to enable customers to use the software yourself so that you're not reliant on external consulting, even though we do provide consulting services, and we're happy to do so. And there's a lot of different options. There's training options, there's advanced support and mentoring, and also consulting. So yeah, there's a lot of different options, and it just depends on what your needs are. I have another question of, I don't own HPC hardware, but need to perform CFD solutions. Is there a recommended cloud option? And the answer is yes. There are several different cloud options. Siemens has developed and introduced a product called Simcenter Cloud HPC. And what that allows you to do is access cloud resources through the simulation software application directly. And it's very good for a couple of different use cases. And what I use is Rescale, which is a great front end to access the different AWS, Azure, Google Cloud, the different cloud providers. So that's the one that I prefer. But yeah, there's a lot of different options. Can we model humidity in addition to temperature in STAR-CCM Plus? Yeah, this is one of the key offerings. Simcenter STAR-CCM Plus does offer evaporation. for a couple of different applications. It offers it for thin film, and it offers it for multi-phase VOF. It offers it for a couple of others. Like, for example, there is a battery slurry case. Like if you have a slurry or some type of a battery precursor, there is evaporation enabled. And I believe that's through the DEM, the discrete element modeling physics. So yeah, it depends on your problem, but yeah, evaporation is included. Okay, I don't see any more questions. So again, I would like to thank you for your time. And if you have any follow-up, please feel to reach out. We're happy to talk.